Okay, example 2, basically the same exact directions. Find the zeros, write the polynomials and product of linear factors. Once again, if I start with the rule of signs, s of x has 1 sign change, 2 sign changes, it stays positive, 3 sign changes. So for positive solutions, we have a total of 3 sign changes, so either 3 or 1 positive solutions. If I look at s of negative x, it's going to be positive x to the 4th, change to positive 6x cubed, stay positive 10x squared, change to negative 2x, stay negative 15. Positive, stays positive, switches, that's 1 sign change, stays negative, so there's 1 negative solution. So either 3 or 1 positive and 1 negative. Second, if I look at my p over x, or p over q, possible rational roots, since we do have both positive and negative solutions, I do want to put plus or minus and everything. Once again, q is 1, so over 1 just gives me a list of p's. All the p's go over 1, so it's just p's the list. So plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15 are going to be my possible rational solutions for this. I'm going to clear all these out. I don't want to find just 2 answers. I don't want to find 3 answers. I could find all 4 answers, but I just want to find 2. So clear this out. So if I type in my function x caret 4, press to the right, minus 6x to the 3rd, press to the right, plus 10x squared, plus 2x minus 15. Type in my possible rational solutions one at a time. 1, negative 1 works, 2, negative 2, 3, oh, 3 isn't, sorry, 3. Yeah, 3 works, okay. Shouldn't have even done 2, sorry. So negative 1 and 3 both work, right? So again, once we get some answers, negative 1 and 3, you can actually write the answers down, but again, you want to do synthetic division to reduce the polynomial down to a quadratic. So it doesn't matter which one I start off with either. I'm going to start off with negative 1, but I could have just easily started off with 3. Any solution will work. 1, negative 6, 10, 2, negative 15. Bring the 1 down exactly as is. Multiply, you get negative 1. Add, you get negative 7. Multiply, you get positive 7. Add, you get 17. Multiply, you get negative 17. Add, you get negative 15. Negative 1, negative 15. Multiply, you get positive 15. Negative 15 plus 15, 0. Starting to sweat a little bit on that one. These numbers are getting bigger, but yeah, work yourself out. All right. And then we tried positive 3, same scenario. Now this is our reduced polynomial. That 0 is gone, so bring the 1 down. 3 times 1 is 3, plus negative 7 is negative 4, times 3 is negative 12, plus 17 is 5, times 3 is 15, plus negative 15 is 0. We get a remainder of 0. The reduced polynomial q of x is going to be x squared minus 4x plus 5. We want that equal to 0. Okay. It doesn't, well, does it factor? No, it doesn't, because plus it had to be minus 5 to factor. So here I'd probably use my quadratic formula program. So I'll go to my programs, choose quad, and my coefficients are 1, negative 4, and 5. And it results in 2 plus I and 2 minus I. Okay. I turn my calculator mode to a plus bi form so it knows about imaginary numbers now. If you have it in real form, it won't work. So 2 plus I and 2 minus I are the results. Anytime you get a complex answer, both the answer and its conjugate are going to be solutions if all the coefficients are real. If you have real coefficients in a polynomial and you get a complex solution, you immediately get its conjugate also as a solution. So altogether, those 2 answers plus the 2 answers I have above, negative 1 and 3, are all the solutions. So find all the zeros, there's all the zeros. The other direction, again, write the polynomial as a product of linear factors. Okay, once again, looking at this, our answers, we have 4 different answers. There's no multiplicity happening this time, so we should get 4 factors. P of x equals. Now, I'm going to identify each of these with different colors. So this one's 2 plus I, this one's 2 minus I, this one's negative 1, this one's positive 3. Okay, so when I'm writing these out, I want you to see where they're coming from. So I'm supposed to subtract each factor. Notice the complex numbers are binomials. So when I subtract, I got to distribute. So it's going to be x minus this, it'll be minus 2 minus I. When I do 2 minus I, it's going to be x minus that, so x minus 2 plus I. And then when I got negative 1, it's going to be x plus 1. And for positive 3, it's going to be x minus 3. So when you're writing this polynomial in factored form, linear factors, x minus each answer. Again, binomial factors, make sure you distribute that minus sign through to get both signs changed. It doesn't, in the long run, matter, because if you do the same mistake on both of these, that'll say plus, that'll say minus, you still got the same factors. But it's good policy to have the right things on your paper and not having two mistakes make a right answer. So it's good to have good form in your work.